Now let's check it. Yeah, it is on red ring of death, and if I check for the code, it is 0, 0, 0 and 1. So I have never ever believe in the codes given by some hackers. At this moment it seems that it is a power issue. Your fan is not running. I must disconnect this wire. This is standby wire. Disconnect the fan jack, and this jack is for installing a hard internally. We have fixed this SATA cable and given 12 volt to the power of the hard 12 and 5 volt, and this is ground, black wires for ground, and we can use and fat HDDs in this console, fixing the hard in the console at DVD-ROM, and replacing a DVD-ROM we can insert a hard disk. So let's open it. Guys, board is out and the modification chip is installed underneath this motherboard. Let's check it again. Yes, it is on red ring, and code it shows 0, 0, 0, 0 and 1. Okay, so let's check for the power supplies, because this code shows that this problem is related with the power section. And in this console, as you have observed in PS3, there are many sections, and there for each section there is a separate power supply. Somewhere is 1 volt, somewhere is 3.2 volt, 3.3 volt, somewhere is 1.2 volt, and this is for this supply is the whole supply is for GPU section, and the whole supply that consists of 6 FETs and 2 coils. This power supply is for CPU, and this power supply, it consists of 1, 2, 3, 4, 5, 6 FETs and 2 coils. This supply is for GPU, and here it is a voltage regulator. It is for 3.3 volt. These volts are used to operate the USB. In some boards you will not find this component. For this we must have 3.2 volt. For this purpose the circuit is designed here at this place. This is, at the moment it is empty. 3.2 volts are designed or obtained from this circuit. If this FET is not here. So this power supply, there is another power supply, this one, it is for the RAM of CPU, and this power supply is for the RAM of GPU. So let's check for the power supplies, are they operating or not. We must check it. So this power supply is 12 volt, and this coil also relates with the 12 volts. This power supply generates or get into this motherboard after pressing this standby button, and here it is 5 volt. 5 volts are available, and 12 volt must we check for the 12 volt. I am going to turn it on. Yes, 12 volts it is available, but due to the problem the 12 volts drops to 0. Now check for the oscillations. This part and this part, and these are the two FETs that drives these two FETs, and this FET drive these two FETs. This pin is the gate for this FET, and this one is the gate of this FET. We should be precise not to check when the motherboard is running on these pins, because there is a sort of high oscillation. If the oscillation due to any reason have a surge or distortion, these FETs can be blown up, or maybe the CPU may be damaged. So we should be careful about this pin and this pin. So we will check for the volts or oscillation on these. I think now it is visible for you. We must not check on these gates of this FET and this FET. This is the gate and this one is the gate. It is cathode and this is anode. Cathode and anode. So we will not check on the gate because it is dangerous for a motherboard to check on gates with the power supply running. So we will check here for the oscillation, is it available or not. So I will turn it on again. If you can see, yeah, there is no oscillation, and this one must have no oscillation. I am turning it on, no oscillation, and here it is to no oscillation. Turning it on, yes, no oscillation. And now check for these GPU supply, no oscillation. It is horrible. No section is operated and no section is operational. 12 volts are available, but oscillation, no oscillation. Same like we will check these supplies. I will check here for the oscillation, no oscillation, and here even no oscillation. This board is completely dead. Wow. So it is really a power section problem. Powers are not running or in order. So I will guide you some more things that these FETs are driven by these two oscillators, this one and this one. This one is the output for the gates and this one is the output for the gates, this one. And now I will check in cold testing for a short. Turn component tester, and now I will check for the short. Now we can check it on gates. We must check for the gates either they are if it is short or not. This is fine, 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 and here it is fine, and yes, it is fine. This one fine, it is not short, and this one it is also fine, and this one fine, 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 and one more underneath this heat sink we must check. Yes, it is fine, not short, and here it's fine, and here it is fine. So guys, all FETs are fine. Oh my god, then what should be the problem? And now in more detail, the power supply for the CPU, this is the power supply for CPU, and these two FETs are driven by this chip, this one. These are the outputs for the gates of FETs. These gates, this one and this one and this one, and this power supply is operated by these two oscillators, and these RAM power supplies are operated by this chip. This is a chip. It also goes bad many times. We must check. It's fine. Here it is fine. There is no short. So FETs are fine, and now check for the gates output. It's fine. Here it is fine, and these outputs, it's fine, 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 they're fine. Wow. Now, according to my theory, because no component has any kind of oscillation, there must be an oscillation to operate the power supply. So power supply oscillators, these oscillators, this one, this one, this one, and this one are not working. These oscillators are driven by Southbridge, this chip, and HANA chip. So Southbridge is fine because standby volts are available. This button is working. We press this button, it comes to live, but there is no oscillation. So for this, HANA must be involved in this section. This is the HANA chip. It is for the HDMI output. It has a HDMI decoder chip inside of this chip, and the HDMI outputs are on these resistors. Yes, you can see these lines are going to HDMI port via these coupling resistors. These are the fuse resistors. Yeah, this is good, 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 fine, fine. This one is open. Why? It has no connectivity. Let's see it. This one and this one. So check for the output. This one, these resistors are for the output. It's fine. We will check here for the short, either to check that our chip is bad or good. These are fine. So why there are here we can't. Oh my god, it is a sort of rust. I hope it should be like that. This should be like this, but it is not. It's mean there is some kind of rust problem, and this one is right away open. This is good, this is good, this is good, this is good. So now we will go back for this trace. This trace is available here, yeah, and here you can see that it is connected, but here is a rust issue. The print is break. Yeah, here I scratch the paint of this trace. It is fine, but on this capacitor it is broken. Same like here it is open, and I will scratch for the print point, and yeah, it is. But these are the outputs for the HDMI port from this HANA chip. This may cause no display on the screen, but it is not related with the problem of our power section. So for power section we must check for it in detail. So I will check it on my component tester. Let's check for its biasings. As you know that in my last video there was a fault I found in GPU biasing section. A resistor was changed its value, and we replaced the resistor, and that was okay. Now these are the biasings. These are the outputs for this south bridge, but these are the biasings for this HANA chip. So we must check these biasings. It's fine. And now with this one, it's connected. It is also connected. It is also connected. This one is also connected. This one is also connected. Here it is the logic, and all these things we have already checked. There are two prints are broken. This one, sorry, this one and this one. This one is semi broken, and this print is fully broken. So we will connect it. So it means this board is humidity damaged or water damaged. but looks very fine. So biasings, some biasings are here. These are the connections for this GPU. No, it should not be. This one is connected, this one is connected. There are some resistors here. This one is connected and shows logic. It's fine. And this one is, oh, here it is. It shows the resistor but not the logic. Why? So guys, must check it in detail. Here it is. You can see in the oscilloscope. I must show the oscilloscope too. This one. Yeah. It is showing only the resistor value. Yes, resistor is fine. Oh my god. This one is fine and it is pull up, and this one is pull up in series, and here it comes on this dot. And now we should go back for this. Yes, here it is. I scratch the paint and I found logic there, which is not connected with this point. Same fault, guys, like this. This one and this one and this one are the same faults. We must print these 3 traces, and afterward I will check either the fault is removed or not. Yes. Now guys, you can see these logics. I will check it again for you. This one, it's look fine, and this one, it also looks fine. Again, this one looks fine, and this one looks fine. And here was the main problem for this print, and now it is showing logic. So let's check it again. Giving the power, HDMI cable, and turning it on. Yes, it must boot now, because the oscillations, check here. I will check for the oscillations. Yes, there are oscillations on all FETs. Here, here, and must be here. Yes, and here too. Yes, here. Power supplies are operated. As you can see that this was the first jumper I made here. That was the main problem, that the FET's oscillation was not available, because this one is the biasing of this HANA chip. And second jumper I put here, on this resistor here. This one was connecting the HANA output to the HDMI port. This trace is going to HDMI port, and the third one was here. This one is also coming out of the HANA chip and going to the HDMI port, coupling with these resistors. These are the fuse resistors. And now in the last I have to put another jumper here. This is the coupling from the CPU to the south bridge at this capacitor. This capacitor, the trace that is going to the CPU, this trace that was going to the CPU was disconnected from this capacitor, so I have to put another fourth jumper here, and now I will check it either it is okay. Hopefully now it will boot up with the display. Let's check it. And now I am going to power it on with the standby button. Yes, and should I go to, yeah, now it has been booted up, and now you can see here the display. Wow. So guys, thanks for watching my video. This was hopefully will be very helpful for my followers. Like and subscribe. Thank you very much. Goodbye.